Okay, so we're going to look at another question from the sample paper I put up for YouTube, and it's question 2, integration. Right, I'll just go to a new screen here. Find the following integrals, and there's part B is limits, and just take that to 2 decimal places. Right, okay, so we'll kind of go in and attack part A there. Right, I'm going to take it down because it's always with integration. There's a thought process to it, and it's kind of I don't know what's the best way to say. Is it ruling out a method or ruling in a method or trying to figure out what method I need to use? So I'm just going to take that again. That 3x uh, sine of 5x. Right, that's what you see. That's what's presented to you, and you're just told integrate that fella there. Right. So there's the thought process with integration questions are always the same. Right. It's first rule out that is it an easy integration question or is it a difficult one. What I'm going to do is I'm just going to exaggerate that the tree x there isn't, it's not that there's three terms, a tree and x and a sine of 5x there. Think of that 3x is sort of stuck to the x there, that you can put them, you can think of them as one item. Well, this isn't an easy one. Why? If it was just 3x, yeah, I can do this business of up the power divided by the new power. Sine of 5x, there's too much going on there for this to be an easy question. And maybe the easiest way to say it is, the easiest argument would be that x is stuck. 3x on its own, fine. Sine of x on its own, well, there's a 5x. There's too much going on for this to be an easy question. So it's not something that. So if you think that you can just do this by clicking your fingers, you're missing the point of the story. X stuck to sine. X is in the okay, so x is in the logs tables on its own. Sine is in the logs tables on its own. But like differentiation, if you have x stuck to sine or multiplied by sine, you need something other than just. You can't just do it directly without using one of the rules. Right. So we have that is an easy question. We have that ruled out. What else do we need to rule out? Well, it's not that there's anything to rule out. We need to rule in something that there are only, barring partial fractions, really and truly, there's only two rules for integration: by substitution or by limits. We need to figure out which one this one is. Right, well, the best advice I kind of said in class is, what do we have? We have two expressions of x. Can you see that there? Right. Even if you have to completely slaughter your picture here with arrows and figures and everything in circles, that's fine if it gets you started on what method to use here. But at least start by saying, right, where are my expressions of x here? There they are, circled. And usually we might have the spare, I'll call it an outside function. No, it's just a function, an outside function, the outer function. Usually we leave that alone, and that happens even when we're doing substitution. Right, is it the case rule in or out substitution first? Substitution will work if I can move from one circle to the other, if I can differentiate one circle and get the other. This magic phrase of give or take a constant. So I'm going to draw two arrows and say just check each one. Right, I'll do it that way first. Starting at 5x, can I differentiate it and get 3x, give or take a constant? Well, if you differentiate 5x, you get 5. Is that 3x, give or take a constant? Well, yeah, I'm off by the 5 and the 3, but no, there's an x there as well. There's no way I can just fiddle about, multiply that 5 by something and get an x out of it. So that's ruled out that way. The other way, let's try the other way. 3x, the derivative of that's a 3. Is there any way I can multiply 3 by a number and get 5x? No, you need it to multiply by an x also, so that's ruled out. Right, we have both directions ruled out. It must be an integration by parts question. So after, I'm going to have to retake that whole thing down again, and that's fine. So I'm going to hop into, without any more argument about the whole thing, I'm going to hop into the integration by parts routine. So I'll sort of write it up. I'll write the whole thing up again. So it was, and put that 3x just to clear it up that this is, I can think of that as one term, 3x by sine of 5x. Okay, do the u late business underneath. U equals late. And again, yeah, that's fine. Right, start pointing and start pointing your terms into that there. Right, so this 3x, well, if it means that you have to say to yourself, sorry, if it means that if you have to rule out, well, it's rule stuff out if you can't see what it fits into. Well, it's not a log. There's no log there. Trig is for trigonometry or sine cos. 3x, there's no sine or cos there. E is for exponential. 3x doesn't have an exponential. So by elimination, you have it as an algebraic function. Okay, be careful now about that. This I can, when I'm doing integration by parts now, when I'm applying the two terms, yeah, I have to consider sine of 5x, so I don't sort of just circle the inside. You know what I mean? It's the whole thing. I have to put the whole thing into one of these letters, right? Sine, well, that's a trig function, so there it goes in there, right? Who came first? U came first. So that's going to be, or 3x fitted into A. Who fitted into the leftmost on the list? The 3x. That's what my U is. And everything else is dv. Now, the thing that I'm guilty of is I didn't write the x there, the dx at the end, because dv is everything else. Once you choose u, dv will be everything else, including the dx part. Right, so I'm going to, on the left, I'm going to write down what my u is. So I'm going to say u equals 3x. And then over on the right, dv, everything else is dv. Everything else inside that integral symbol is sine 5x dx. Right, differentiate this way, integrate that way. Okay, so it's almost, you just follow the same routine, exactly the same thing each time. Differentiate, I'll write down du dx, and the dx is going to come up now in a second. Right, so du dx, the derivative of that there is a 3. Underneath that, take the dx up, but say, right, dx is downstairs that time, it'll go up upstairs the next time over on the other side. But say to yourself, well, be careful, there's a 3 already there upstairs waiting for it, so I'll just keep the 3 in a bracket. I've just introduced it. It's not for no reason. It's not that this is incorrect, it's that it'll keep it safer. It'll be safer later if I just keep that 3 in a bracket, because I can move it about then more easily. Right, what's the routine this time? It's introduce your integral symbols. dv, sine of, don't touch anything here, sine of 5x dx. The next line, that becomes a v, because there's an invisible 1 there. What did you differentiate in the first place to get a 1 with respect to v? It was just the letter v itself. So that is a question, and it is, what did you differentiate with respect to v to get 1? That's the English for that maths question there, and the answer to it is the letter v itself. Right, the answer to this isn't so easy, but I think that we're making, like the argument for the partial fraction question, we meet this so often that we're just going to memorize it, that the integral of sine of number x dx is, well, and the log tables think of it, well, sine is back up to minus cos, but the number I divide by the number, so altogether it's the most difficult one, minus 1 over n cos of nx. And if you, yeah, now it's cheeky that we're memorising it, but I think this integration by parts questions kind of feels like a long question. We'll not get bogged down by mixing up the two things. So if we just see a simple enough one, it's not that it's simple enough, with just a number in there, we'll kind of just say to ourselves that we can memorise it like that there. Right, okay, so but unfortunately I haven't enough room there to keep that at the side. Well, I'll just kind of put it over there. So it's a thought that it doesn't have to go into my answer. It's just a thought that I don't have to include it in my answer. Right, okay, so that goes up. Take the divide by the number and change the sign. Minus 1 over 5 cos of 5x. Again, with integration, don't add the plus c now, add it later. Add it once later in the formula. Right, so I'm good to go now. I have my U and my DV. I have no room now for the thought anymore. He'll have to go. Sorry. Yeah. Okay. Right, so the formula goes like this. In the logs tables, again, I don't have a copy of the logs tables on the screen. You'll be given the logs tables in the exam. Learn what page it's on. So don't walk in the exam not knowing what the formula or what the page number it is in. The formula goes like this, and sure I'll use the colours while I'm at it. It's the integral of UdV equals UV minus the integral of V du. Purple again, V du. Right, so I'm just going to sub everything I have into that. Now, when you sub into the left-hand side, in a way you don't have to think about it. What you should be getting is your original question, because you let that be u and that be... So you should be getting back the original integral. So it means that you take this bit down, that bit there, you should get back this bit when you sub that in. But if you want to convert, if you feel like you have to sub it in, that's fine. But really you could just jump and write down what you started with. Either way, I'll put it in anyway. I'll say, sure, right, we'll take our time, we'll put it in. There's my u is 3x, and my dv part is that fella there, sine of 5x dx. Now you say, why are you not putting in a bracket? I could put in a bracket, but I'm just kind of showing you that it's no coincidence that I ended up back with the original question that I started with, 3x sine of 5x dx, because that was the split that I started with. What you have to do with integration by parts question, it's all about the left, the right hand side. That's the part that you're working with. 2 seconds. Sorry. Anyway, okay. Equals, this is now what I have to worry about here, getting this bit right. uv minus the integral of v du. Okay, right, so u again was 3x, sorry I have it rubbed out, or it's off screen there. I'll try and move that screen up a little bit. Okay, just about fitted in. 3x. V is this guy here that'll barely lift enough room to write in, but anyway, 5th cos of 5x. Okay, and then within the integration symbol, I've that repeats itself over there, minus 1/5 cos of 5x. Very bad writing here, sorry about that, didn't leave myself enough space, by du. There's my du fella over there, 3 dx. Right, so I can kind of bigger clear right now underneath here. So there's nothing to worry about here. There was no limits in the question. I have nothing to worry about here. It's I just keep taking that down. I suppose we can worry about cleaning it up later, but what I'm going to do is say, well, that bit's done. I don't have to integrate that. This bit you have to integrate, because the integration symbol's there in front of you. It means integrate the following. So you're not done, but there's no integration symbol here. I'm done with this bit. But while I'm at it, I'll stop changing colours as well, I think, just to get through this bit quick. Minus 1/5 of cos of 5x. So I'll leave him alone and not worry about him. Minus, okay, what I'm going to do with this guy, well, I'm going to say, now the writing is not good there, so what I'm going to do is just kind of rewrite that thing again by giving myself enough space there. Minus the integral of, just to get that in there, minus 1/5 by the cos of 5x. That wasn't much better, was it? But anyway, it'll do the job. Right. Okay, so kind of like when we were doing substitution in class, kind of said the same, in either way, constants out. Right, so there's two constants there, minus 1/5, and that minus 1/5 and that 3. What I'm going to do, just going to carefully take them out. And I'm not going to try and multiply them all in one go. I can do it, have plenty of time to do it later, because there's going to be a lot of equals going on here. So what I'll do is I'll just take them out anyway. So that's not an equal, minus. Right, so take that out, that minus 1/5, take him out inside a bracket there, and worry about the whole thing later. There he is. I'm not even going to worry about what minus 1/5 by 3 is. I'll worry about it all later. And and there's the 3 coming out there then. Just take them out and leave them like that for the minute, and then you don't have to worry about there's going to be problems with the minus by minus there. Leave it for a minute. Right, when I take those constants out, I'm just left with that purple cos of 5x. And the dx bit, but think of the dx part comes hand in hand with the swirl symbol. They're part and part, they come together, so they're part of, that's a maths question. It means what did you differentiate? That's the maths, that's the English for that there. What did you differentiate to get cos of 5x? Anyway, okay, so again, keep working with this thing here. Well, we're all right here. Please. Okay, equals again, right, 3x, leave all this stuff alone, minus a fifth cos of 5x. Right, if you wanted to worry about that and go with the calculator and say, right, type what you see, again, look at what happened when I press minus, so something on the screen before answer come up, just make sure that doesn't happen. Start again, minus bracket, minus fraction of fifth. Bracket 3, just see what you get. I get 3 over 5, there's an invisible plus there, don't just write 3 over 5, write plus 3 over 5, yeah, plus 3 over 5. Now, for this guy here, I'm ready now. I should have been, so when you get when constants come out, typically you're left with something that's either in the logs tables or that I'm kind of forcing you to memorize that because we meet them so often. And again, like the sine of 5x, well, that wasn't a thought that rubbed out earlier on. I'm going to say, well, I'm going to memorize that there, a cos of number, the integral of cos number x. So I'll write number as capital N. That's not too bad this time because there's no plus or minus problem here. Cos goes to sine, and I divide by the number in the inside, so altogether it's 1 over n sine of nx when you integrate cos of number x. So that's going to use over here. So I'm ready now to integrate that purple cos of 5x fella using that green thought. Plus, because I'm integrating now, and I mean, I suppose if you wanted to say, because we're so used to when do I use the square brackets, when do I not? There's not a problem with using square brackets anytime in math you want. It's just you never see them, or it's very rare that you use them. It seems to be the only using them with the limits. So when you're ready to integrate, say, always use the square brackets if it kind of keeps things safe for you. So always use the square brackets if you want to when you're integrating. But we have no limits there, so don't have to worry about putting the limits over here or anything. But the cos of 5x, its integral is this here, it's 1 over 5 the sine of 5x. That's its integral. Stop writing swirl, stop writing dx symbol, they're gone. Now, right, I'm going to move that thought down the page, but that's where that came from. Finally, is there anything left to do? Well, we'll just sort of, as much best as we can, we'll say, right, well, we had a fraction there, and it was an invisible 1 over there. If I want to put it, well, I'll put that in a different colour. There's an invisible 1 there, so I have two fractions meeting together, but there's a minus also. So what I'm going to do is say, altogether, that's minus, top by top, there's an invisible 1 there, so it's 3x. There's something wrong with that part of the screen, sorry about that. Minus 3x, and there's a 1 over, again saying that there's an invisible 1 at the bottom. 1 by 5 is a 5. Cos of 5x. Again, top by top, bottom by bottom, so I'm left with plus 3 over 5 by 5 is 25. Guilty of it. What am I guilty of? Forgetting to add the plus c at the end because there's no limits. Should have done that up at that step. Anyway, it happens. Don't forget it. Sine of 5x. 5x plus c. Right. Anyway, that's my final answer. Okay, that's that part. Integration by parts. You've it all done. Let's go back up now to part B. I'll take this split down with my copy at the end. Right, a new fresh start. Okay, so what's going on again? Go through the thought process. I mean, right, functions stuck together, integrating functions stuck together. We have an x squared. Even if it was an x squared minus 1, x stuck to sine as we saw before. There's two, in a way there's just too much going on there for this. This isn't an easy one. So I need rules. Is it by substitution or is it by parts? If I do the usual business, if you can't see it, but it should be that the inside there's an inside function, and if I differentiate it, do I get the outside expression of x? This is the way it should go, but I understand that you would say, that's all I know is I just know about your two expressions of x business. So if it means that you circle both of them and try both of them out, that's fine. Let's do that. Let's go forward and backward. Is it true that if let's start here. If I differentiate that, I get 2x. Is that the other circle? Do I get the other circle by just multiplying by a constant? No way, because you have an x cubed minus 3x in that other circle. So that way is out. Right, try the other way. I'm purposely going to put it in green because that's the way that would work. Right, when I differentiate that, sure, right at the arrow, I would get 3x squared. Hopefully you can see that now in that video. That mightn't come out well in the video. I'll do orange. 3x squared minus 3. Is that this expression, give or take a constant? Looking at that, can I get that outside expression by just fiddling about with a little constant? You can, because that is that expression, but I'm off by a constant. I'm off by 3. So if this happens, you can get one x expression by the other. So I'm going to put a big green tick there to say yes, I have it. If I get the one by differentiating the other, give or take a constant, that's my cue, that's my hint that substitution is going to work here. Right, okay, I'm going to rub all that out, and I have it that this circle gives me the other circle, or this expression of x gives me the other one, so I'm going to let v be this expression of x. So from here on, integration by parts is a bit tricky because it depends what the u and the v is. But with integration by substitution, once you get that v, I could rhyme out, I could say the steps. It's always the same steps each time. So v equals x cubed minus 3x. And the steps, I could rhyme them off in English. They're going to be find dv dx, fiddle about with the constant to make this appear, rewrite the integral by replacing all of these guys with v's, including the limits, then constants out, dx is cancelled. I'm sure it doesn't make any sense maybe when I'm saying it so much. Maybe I'll just continue with the question, but we'll see it all in action now in a second. But what I'm saying is, once I get that v, if you know it's substitution, you get that v, you're home and dry then. You're just going through the process of doing it. Right, anyway, right, so dv dx, the derivative of this v here, well, it's 3x squared minus 3. That's not what I want. I want x squared minus 1 on the outside there. Right, so what do I need to do? Well, I'm off by a 3. How will I get rid of those? I want x squared minus 1. So you can say it, there's two ways of saying it. Divide by 3 or multiply by a third. But I'm going to say it like this. I'm going to multiply by a third. So a third dv dx. That'll get rid of those 3's. I'm left with x squared minus 1, and that's exactly what I want in the as the function there on the left. That other expression of x within the integral symbol. Right. I'm not ready to go yet because I need to find new limits. So new limits. Underline it because you have a new top and a new bottom limit to find. What I do is sub the old bottom and the old top limits into my expression for v. So I put it like this. All I need now is that purple expression for x. So I'll say new top is got by subbing in the old top limit. It's off screen there, which was a 2. Into the expression for v, right? So v of 2, what I'm missing there, you see, is you'll say, why? What do you mean v of 2? Well, what's missing there, that's what the full version of that there is v of x. V of x equals x cubed minus 3x. So I'm subbing in a 2 into it, and I get 2 cubed minus 3 by a 2. So I get 8 minus 6 is a 2 there, or go to the calculator and do it. All new bottom. Sure. New bottom, v of 0, where the old bottom was 0 there. So I'm going to sub that in to get the new bottom. That's 0 cubed minus 3 of 0. I just get a 0 there still. Right, once you've all replaced now, you're ready to rewrite your integral. So what I'm going to do is, I was using this business, so I'll go back up and call it I in class, but you don't have to do that. You can just, what I'll do is put a little section heading, rewrite integral. Right? Underline it again because this is what you're doing. Again, the English or the writing isn't great on the screen. Sorry about that, but it'll have to do for the moment. Right, so I'm starting with that there, and you didn't, of course, you're not copying and pasting it onto your sheet. So I'm just going to start from that point and say, right, my original integral was this here, 0 to x squared minus 1 by the sine of x cubed minus 3x on the inside of that sine function. Now you're going to rewrite all of that by using your stuff that you found up above. So as best as I can, I'm not going to fit all this into the sheet now, so but I could zoom out a little bit. I'll zoom out there. That'd be the best thing to do. Hopefully you can see, because I can see everything now then. Right, so you're just rewriting everything now in terms of v. Right, so your new limits become, that equals your new limits, the new bottom was the red 0. Your new top was the purple 2. That x squared plus 1, that's what you got when you forced that to appear in your workings, when because you were off the original inside function v. The other expression for x was v but off by a constant, so it was that was a third dv dx. Then you're left with, again, that'll throughout when you were deciding should I use integration by parts or by substitution, this didn't play a part in anything, because the job was identifying this inside function. But it plays a part when you start. It doesn't play a part when you start the substitution question. It didn't appear anywhere here. It does play a part when in integration, because it's what you need to point that into the trig category. Anyway, so that's what it feels. You don't see this sine function in your workings until at this stage, until you're nearly done, right? But anyway, here, so it only reappears in your workings here. Sine of, and this expression was your v, your purple v that you chose originally. Okay, so that's v, right? And again, I saw in the class test people were doing a mix of this entire thing should be written, well, after I do this next step there should be no v's left, so you shouldn't be at this. You're missing the point if you do it like that. If you don't replace that inside, you're missing the point. You're not kind of going through the process correctly. Okay, so it should be a v there. Sorry, it's taking a while to get through this. Anyway, dx. Right, I'm going to zoom back in here. Right, here I am. Okay, the purpose was to rewrite the entire integral of v in terms of v only. I still in a way have dx's. So if it's sloppy, but it works. If I think of it that there's a dx in the bottom and the top, it'll always happen that the dx's, if they were fractions, they would cancel. So that's what I say to myself, dx's cancel. And I'm going to take my time, even though some people would say, right, what I'm going to say is dx's cancel, constants outside, and dv out to the very end. That's what I was saying, it's the same thing each time. Right, so but I'll take it in little steps. First thing, dx's cancel, so that equals everything, but with the dx's cancelled, you'll be saying, well, I'm left with my dv there and my sine of v there. Now I suppose in class I did surround that all by brackets, so if we did that we would have that surrounded by brackets, but it's not the end of the world. Just be careful what you're doing when you're doing that. Right, the next thing I said, constant out, so that'll be the next step. There's my constant, a third, so I'm going to pop him right outside the integration symbol. 0, 2, and if I'd done that I'd be left with the dv there. Now I'm kind of been Now suddenly, right, no brackets at all over here. Maybe we'll say, right, the bracket moved out with that third. Next step, DV's out the end. It's always the same, and it's always the same then. Hopefully, well, hopefully you're left with something that's directly in the logs tables after you'd put that DV to the end. Right, DV to the end, and you're just left with sine of V. That's definitely in the logs tables, except, yeah, it's written as sine of X, but you can treat your X as V. You can treat your X in the logs tables as V. Okay, so the logs table says that sine derivative of cos is sine, so that goes back up to cos again, right? So you're doing the process of integration. You're up the power divided by the new power, or you're reading the logs tables. Either way, you can, when you're doing the process of integration, when you're integrating, put your answer in, and we kind of said, sure, put them in square brackets. Or, well, it's because it's limits, we will put them in square brackets. There we go. We don't need to add a plus c here because there's limits. Right, put in the top. So the way this goes is, if there was no, suppose there was no third, suppose there was no, how will I do this? Suppose that wasn't there, then I would do it like this. I would say top limit minus the answer I get when I sub in the bottom limit. But because there's a third there, I have to worry about that and keep that. I'll have to do it like this. The third is going to multiply the answer to all of this business of subbing in the top minus subbing in the bottom, right? So I'll keep, there's no harm, keep your square brackets, even though you mightn't be, there's no harm with them, right? Cos of 2 minus cos of 0. Oops, the minus is already taken care of the cos of 0 over here. Right, I can type that entire expression in the calculator as I see it. Now, when be sure that when you go to your calculator, that is in radian mode. You don't usually, it won't even tell you that. For even though I know for engineering, it's the when you have a maths course. How will I best say this? Right, for me, for my maths course, or this maths course, we never type in degrees. Everything, when we're subbing in something into sine or cos, we're talking about radians. So make sure my calculator happens to be in degree mode there. So I'm going to change it mode, however you have to do it in your calculator mode. Yeah, I have to go setup for these calculators. There, radian 4. Now now I'm in the little r there. Okay, so a third, type what I see, a third. It took a while now to go through. I didn't intend this question to take so long, but anyway, it was between the screen and the. Anyway, cos of 0. Close that bracket twice, equals minus to 2 decimal places. I look out, don't stop, you know what I'll do, because I'm going to draw that out. Where's this? New. I'll take that over there just to make sure you know how to round to 2 decimal places. Okay, so to round to 2 decimal places, you don't just say, sure, I'll stop there at the 7. You also consider the third one. If the third one is 5 or more, you put the second decimal place up. Otherwise, you keep it as it is. That is not 5 or more, so 2, so I keep the 7 as it is. If it was 0.476, you would write down, you would change that 7 to an 8, you would up it to 8. But anyway, it's fine as it is, so it's minus 0.47. Minus 0.47. That's my final answer. Then put a little square, and you're done. Is that that's all done, isn't it? Yeah. Thank you. Stop.